This is your review podcast for our measurement of matter unit. There are 4 basic objectives, although it does cover a lot of material, so this one will be a slightly on the longer podcast. As always, use it to help you review or to help you learn. Skip the parts you don't need or listen to the parts that you do need more than once. So let's actually combine our first 2 objectives. Objective 1 and Objective 2 have to do with our metric system. Why do we use it? Can we use the correct units? How do you use a tool to find each of the measurements? So for the metric system, it's odd that we are the only country that doesn't use it, for the most part. It's counting by tens. It's an easy way to have something in common with another person so you can talk and understand the same things. You don't have to spend a lot of time remembering that there's 16 ounces in a pound or 12 inches in a foot. It's a lot easier to do 10, 100, 1,000. Here, for reference, is a chart that shows the various countries that have switched over to the metric system in the last little bit, just in case you were wondering. Here are some common prefixes that might help you. Milli means 1/1000th, centi means 1/100th, and kilo means 1,000. That means there are 1,000 meters in a kilometer or 1,000 millimeters in 1 meter. So you can use those prefixes in front of the bases to convert between the different units. So let's get started with measuring length. You can use a ruler or a meter stick, and it would be measured in units like centimeters or millimeters or meters or kilometers. We would want to use the side of the ruler that's the metric side, so no inches. For example, it is 6 kilometers from here to my house. For measuring volume, you can also use a ruler if it's a nice square, regular shape. You could use a graduated cylinder, water displacement, which I'll explain in just a minute, and you could also use a beaker. I don't recommend a beaker, it's not very accurate, but you can get an estimation. There's 2 main units for volume. Either you use cubic centimeters or milliliters. For example, this rock has a volume of 3 milliliters. So let's look at this water displacement method. It doesn't matter how much water you start out with, but you need to measure the amount of water starting, then you drop the object in and measure how much it increases. The amount that it increases is the volume of the object. So for this object, it starts at 7. When you put it in, it goes up to 9. That means that it has a volume of 2 milliliters. For measuring mass or weight, you can use a scale or a triple beam balance. You would measure in grams or kilograms, and for example, this book weighs 5 kilograms. Last but not least, let's measure temperature. We only have one tool, a thermometer. The units we use are Celsius, and for example, this water is 99 degrees Celsius. So for these 4 methods of measuring, you need to use the correct tool as well as tell me the correct units to use. So let's try a little quiz. What tool do I use to measure volume? If I'm measuring the mass or the weight of my book, what units do I use? If I wanted to find the volume of a weird-shaped rock, how do I do it? So let's check your answers. I would use a graduated cylinder to measure volume or a ruler. If I'm measuring the mass, I would use grams or kilograms. And if I wanted to find the volume of a weird-shaped object, I would use the water displacement method. Fill a cylinder with some water, add the object, see how much the object increases or how much the water goes up. So let's take a look at Objectives 3 and Objective 4. They basically ask you to calculate density and to compare density between different objects. So let's take a step back. What is density? Density is comparing how much space something takes up to how much mass there is. Before we get into a couple of ways of how to tell or remember the formula for density, let's look at some relative densities to compare which one is more dense. Now we used the analogy or the example of our field trip in class, talking about how crowded the particles are versus not. So take a look at this particular set of pictures. They're pretending that those are students in the classroom. Which square is more dense, or which has the particles more crowded? If you look at the one on the right, there are a lot more dots than there are in the one on the left, so we would say the one on the right is more crowded. Now with this pair, they have the same number of dots, but the one on the left is significantly smaller than the one on the right. So which one's more dense? The one on the left. There's less space for that same amount. So our formula for density is mass divided by volume. You can use units like grams per centimeters cubed or grams per milliliters. You need to remember the units, don't leave them off. And they're there because we do mass over volume. So the mass is usually grams and the volume is usually milliliters. We learned a heart trick to help you remember that if you take a heart and do a line through the middle, it looks like there's an M on top and a V on bottom. M for mass, V for volume. We also taught you a song. Yes, I know, a song. It goes to the tune Row, Row, Row Your Boat. And here's the song. Sing along with me. I love density, density loves me. Mass divided by volume equals density. Whichever way works for you, you need to remember that density is mass divided by volume. So now let's talk liquids. If you pour liquids together and they have different densities, they will layer. The highest density or the most dense will be at the bottom, and the lowest density or the least dense will be at the top. So let's look at this picture. There are 4 layers. Which layer has the lowest density? The one on the bottom, the green one. Then let's say each of these layers have the following densities: 10 grams per centimeters cubed, 3 grams per centimeters cubed, 6, and 5. Which number would go with which layer? Well, our smallest number is the 3 grams per centimeters cubed, so it goes with our top. Then the next would be 5 grams per centimeters cubed. Then the third would be 6 grams per centimeters cubed. And the bottom layer would be 10 grams per centimeters cubed. So remember that the most dense is at the bottom, the least dense is at the top, so the numbers would go small at the top to large at the bottom. Okay, so here's another, try it on your own. Which liquid has the highest density, the lowest density, and the middle density? Based on what we learned, most dense at the bottom, least dense at the top, the golden syrup would have the highest density, the oil would have the lowest density, and the water would have the middle. Let's look at another example. So here's a container. We have 3 objects. Which object is the most dense, the least dense, and how do you know? The most dense is the circle, the least dense is the cloud, and we know because the circle is at the bottom, it's the lowest, and the cloud is at the top, it's the highest, so dense at the bottom. All right, let's try another one. So which object's the most, the least, and the middle in terms of density? The triangle would be the most dense, the rectangle would be the least dense, and the oval would have middle density. So those were a lot of examples of relative density problems to be able to compare which is the most dense, the least dense, or in the middle. Now let's try some actual calculations. Please remember, use a calculator on these. You're welcome to bring your own, or you're welcome to use the one on the computers, but you do not have to do this in your head. So we have the first problem. Mackenzie has a crayon. We know its mass is 9 grams and its volume is 3 centimeters cubed, and we want to know its density. So we do density is mass divided by volume. 9 grams over 3 centimeters cubed turns out to be 3 grams per centimeters cubed. So let's give you a chance to try another one on your own. McKay has a pencil. It has a mass of 3 grams and a volume of 1 cubic centimeter. What's the density? Try this one and then come back and check your answers with me. So we know that density equals mass divided by volume. We know that his mass is 3 grams and the volume is 1 cubic centimeter. So I do 3 grams over 1 cubic centimeter. Then I simplify that so that the density of his pencil is 3 grams per cubic centimeter. You should be able to calculate density given numbers. You should also be able to remember that volume can be found by using the water displacement method. So sometimes instead of coming right out and telling you the volume is 30 milliliters, I may tell you that the graduated cylinder started out at 100 milliliters and it went up to 130. And by that you would know the volume of whatever the object is 30 milliliters. So you should be able to calculate density using a calculator and using our formula. Let's look at, though, whether things will sink or float. So we know that water has a density of 1 gram per milliliter. If the density of an object is greater than 1, it will sink in water. And if the density of an object is less than 1, it will float in water. For example, if something has a density of 0.43 grams per milliliter, it will float. And if a rock has a density of 3.2 grams per milliliter, it will sink. So now let's give you a chance to try. Tell me whether each one of these will sink or float. The first one, 19.2 grams per milliliter, will sink. The second one, 0.03 grams per milliliter, will float. The next one, 435 over 765 grams per milliliter, you could use a calculator, or you could say that the bottom number is bigger than the top, so it has to be less than 1, so it will float. And our last one is a tough one. That's a really big number. I would plug it into the calculator, or I would still use our trick to show that the top number is bigger, so it will sink. So remember, if the density is greater than 1, it will sink. If the density is less than 1, it will float. So let's take a second and review. What's the formula for density? When you mix liquids, where's the most dense liquid going to settle? And when you drop solid objects in liquids, where will the least dense object be found? Our formula for density is mass divided by volume. You will find the most dense liquid at the bottom, and you will find the least dense object floating at the top of the surface. So here are your 4 goals for this unit. The first one is to be able to use the metric system and use the correct units. The second objective is to be able to use the correct tool for the correct measurement. So if I said, go find me the mass of this object, you would grab a scale, or go find me the length, you would grab a ruler. The third one is to use observations to predict relative density, more dense, least dense, based on what you see. And the fourth one is to be able to calculate density. Mass divided by volume equals density with a calculator. Well, there you go. There's our review for our measurement of matter unit. I hope this helped. As always, come ask me with questions. I look forward to seeing you soon.